Good morning, students. So today we will be discussing the topic questions on the topic application of derivatives. Okay. So in the yesterday's class, we had discussed few questions on continuity and differentiability. Okay. And today we will be continuing with the application of that chapter, application of derivatives. Okay. So in application of derivatives, okay, there are five sections there. Okay, five sections. You need to know some of the related formulas. Okay, so say first section is rate measure. Okay, first section is what, rate measure. So in rate measure, take the first section, and please students mute yourself and join. Don't disturb. Okay, so see, pay attention here. So first section is a rate measure. Okay, so in rate measure, you need to know about the LSA, TSA, and volume of solids. Okay, so based on this solids as well as perimeter and what area, perimeter and area of plane. Okay, plane figures. Okay, so based on this you may get a question. Next, second important topic is normal and tangents. Okay, normal and tangents. So here you need to know the equation of normal, equation of tangents, conditions and all. Okay, next, third one is approximations. Okay, approximations and errors. Next, fourth one, maxima, minima, maxima and minima. Okay, maxima and minima. And then fifth, we have increasing and decreasing functions. Okay, increasing and decreasing function. Okay, so here what I will do is from every section I will try to solve at least 4 to 5 examples. Okay, so from rate measure I will try to solve 4 to 5, normals and tangents, approximations, maximum, minima, at least 3 to 4 examples from every section if we solve. So 120 questions we will discuss. Okay, so you people also try to go through the formulas after the chapter is over. To sit and go through the formulas of this LSA, TSA, the normals and tangents. Okay, so if you have prepared well for the board exams, no problem. Already you know the formulas. Those who don't know the formulas, go through the formulas. Especially these are all 9th and 10th standard formulas. LSA, TSA volume. Go through the formulas so you will understand the solution better. So if you know the formula, you can easily solve the example. Okay, so see, pay attention. So first question here, question 1. Okay, so see the first question. We'll discuss the first question for today's class. Students off, mute yourself and then watch. Okay, off your audio. Jyoti Natekar. Okay, so see, pay attention. The first question is the perimeter of the sector is a constant if its area is maximum and sectorial angle is okay, then the sectorial angle is okay. So we need to calculate the sectorial angle. What will be the sectorial angle? So see, pay attention. We will just try to understand it from the figure. So here we are considering a circle. Okay, we are considering a circle, and this is the sectorial angle. So this is the length of the arc, this is the radius, and this is the radius. Okay, so here we require two formulas. One is, see, perimeter of the sector. The sector is the side which is bounded by two radii. Okay, it is bounded by two radii and what, arc. Okay, so here AOB is a sector and perimeter of the sector will be equal to what? See, it will be equal to 2r plus l. Okay, 2r plus l. Okay, but the length of the arc is given by what? R theta. So we can write it as r is common, so we can write it as theta plus 2. Okay, so the value of the perimeter will be theta upon 2. And then see, if its area is to be maximum, area of the sector, the formula for area of the sector is, okay, A is equal to half r square theta. Okay, so you need to know two formulas. One is L is equal to r theta. Another one is what? A is equal to half r square theta. So half r square theta is to calculate the area of sector. Okay, and this L is equal to r theta is used to calculate length of the arc. Okay, it is used to calculate length of the arc of the circle. Okay, so length of the arc is given by L is equal to r theta, and then area of the sector. Okay, area of the sector is given by half r square theta. So by making use of this formula, the first formula and the second formula, okay, equation 1 and equation 2, we can simplify. See, they are asking when it is maximum. Okay, so when we want to find the maximum area, we need to take the derivative of this area and equate it to 0. So once we equate it to 0, we will get the value of what? Theta. We will get the value of theta. Okay, so here we will simplify it. See, discuss the solution here. So see, first case. So see, they have used perimeter. So P is equal to L plus 2R, and we discussed L is nothing but R theta. So P will be equal to R into theta plus 2. Okay, P will be equal to R into what? Theta plus 2. Okay, so see, R into theta plus what? 2 is equal to P, or R will be equal to what? P divided by theta plus 2. Okay, so here what we are doing is, in the second formula, see, the area of sector is A is equal to 1 by 2 r square theta. So in this, in place of r, we are replacing it by r value is what, P upon theta by 2. So it will be P square upon theta by 2 whole square with theta. Okay, with theta. Then we need to differentiate it. So when you differentiate it, you get dA by d theta is equal to 0, or on simplifying you will get theta is equal to 2 radians. Okay, so theta is equal to 2 radians. That is option A will be the right answer. Okay, will be the right answer. So here you need to know two formulas. One is L is equal to r theta, and another one is A is equal to half r square theta, area of sector and length of the arc. Okay, so in first year trigonometry, you might have come across these formulas. Okay, so here you see this is application. Okay, application of derivatives. Application means you need to make use, you are applying the knowledge of differentiation to various calculations here. Okay, so you are using it to calculate the area, you are using it to calculate volume, change in volume, and so on. So if you know the basic formulas, the examples will be easy. Okay, so this is the first one. Next we will discuss the question 2. Okay, so question 2, the function f of x upon 3 plus 3 upon x decreases in the interval. Okay, so they are saying the function is decreasing, and they are asking us to calculate what, in which interval it is decreasing. Okay, so if a function is decreasing, the definition states that what, f dash of x must be less than 0. Okay, when the function is decreasing, f dash of x must be what, less than 0. So using that logic, we can, using that formula, we can see, first we can find out f dash of x. F dash of x, x upon 3 derivative will be 1 upon 3, and 1 upon x derivative will be minus 3 upon x square. Okay, now we know for decreasing function f dash of x must be less than 0. So keep it less than 0. So on simplifying, we get 1 upon 3 is less than equal to 3 upon x square, or x square is less than 9. And since x square is less than 9, x will be in between minus 3 and what, plus 3. Okay, so see, when x square is, pay attention here. So this is the inequality. See, it is in the form of what, x square less than what, less than a, if it would be, and then always it will be in between what, minus a. X will be in between and plus a. Okay, x will be in between minus a and plus a. Okay, same way it will be in between minus 3 and plus 3. If equal to sign is there, you need to make use of equal to sign. If equal to sign is absent, only less than sign is there, make use of less than sign. Okay, so minus 3 and 3 open interval will be the final answer. Okay, so option A is the right option. Next question, question 3. Okay, so see, if sine inverse A is the acute angle between the curves x square plus y square is equal to 4ax, and x square plus y square is equal to 8, and at 2 comma 2, and then A is equal to. Okay, so here we are using the formula for angle between two curves. Okay, angle between two curves. Okay, and we angle between two curves, the formula is what, at first we need to find out the angle between their tangents. Okay, so we know how to calculate the angle between the tangents. Okay, so we know for a given curve, the slope of the tangent at this point is nothing but the derivative. So x square y square 4x, you need to differentiate with x, and you have to calculate dy by dx. Similarly, you have to calculate dy by dx for the second curve, and then replace x and y with 2 comma 2. When we do this, we will get the slope, the value of the slope, and once we get the value of the slope, we can make use of the formula and simplify it. Okay, so we will go through the solution here. Okay, so see, first they have done it directly. Slope of the first curve m1 is equal to what, 0. So they have found out the value. See here, first what you have to do is, m1 is equal to what, see, m1 will be nothing but dy by dx. Okay, dy by dx at 2 comma 2. So when you do it for the first curve, you are getting the value as what? 0. And similarly, the slope of the second curve, m2 will be nothing but dy by dx. Okay, it will be again dy by dx only. Okay, dy by dx at what? At 2 comma 2 for the second curve, and it is equal to what? Minus 1. Okay, so m2 is equal to minus 1. Okay, so from this, see, m2 is equal to minus 1, meaning is the angle, therefore angle is what? 45 degrees. So angle between this 0 and minus 1, when you make use of tan theta, you will get it is 45 degree. Okay, so you can make use of this formula. Tan theta is equal to m1 minus m2 divided by 1 plus m1 m2. Okay, so if you make use of this formula and simplify, see, m1 is equal to 0, m1 is minus 1. Okay, and then see, again we will get 1 and this will be 0. So mod value, okay, we need to take mod value, so it will be equal to 1. So see, tan theta is equal to 1, or tan 45 is equal to tan 1. Okay, so theta will be equal to what? 45. So we have got this, and they have done it directly. Okay, so here you have to make use angle between two lines formula. Okay, angle between the tangents. Okay, so this will be equal to 45. Once we get this 45, so we know sine inverse a is equal to what? The angle, so 45. Okay, or a will be equal to sine 45, and sine 45 we know the value is equal to 1 upon root 2. So the option C is the right answer. Okay, so see, the first question we discussed on rate measure, second question we have solved on increasing decreasing, and this third question is from normals and tangents. Okay, so now we will discuss the next question number 4. Okay, see, the maximum area of the rectangle that can be inscribed in a circle of radius 2 units is. Okay, so we need to calculate the maximum area of the rectangle which can be inscribed in this, which can be inscribed in a circle of radius for 2 units. So here, say area, first we need to calculate, we need to frame a equation for this, and then they are asking us to calculate the maximum area in a circle of what? A radius 2 units. Okay, radius is what? 2 units. Okay, so see, what we need to do is, see, there is a circle, and in this particular circle we need to inscribe what? We need to inscribe a rectangle. Okay, but we need to inscribe a rectangle which is having what? A maximum area. So here we have to make use of again a maxima minima concept. Okay, so we will try to solve it. So see, pay attention. So see, first we know radius of the circle is equal to 2, and then maximum rectangle is a square with each side a is equal to what? Root 2r. Okay, so on simplifying, what we will get is, we will get a square. Okay, maximum rectangle is nothing but a square whose side is a is equal to root 2r, or we know r value is 2, so a will be equal to 2 root 2. Next, area is equal to what? A square. Area of the square will be a square. So when you multiply, the answer will be equal to what? 8 square units. Okay, so the option D will be the right answer. Next, question number 21. See, if the length of the subtangent, so subtangent concept is deleted for you. This is question. Okay, we will skip this question. Next, we will go to the question number 22. The tangent to the curve. Okay, the tangent to the curve y is equal to x cube plus 1 at 1 comma 2 makes an angle theta with y axis, and then the value of what? Tan theta is. Okay, then the value of tan theta is. So the curve is given to us, also the point is given. So dy by dx we can easily calculate. The derivative at 1 comma 2 will give us the slope, and we know m is equal to tan theta, so we can easily calculate the angle with y-axis. Okay, so with y-axis we need to calculate. So see here what we can do. First we are considering the curve y is equal to x cube plus 1. So on differentiating, we get, say, dy by dx is equal to 3x square, or which is equal to 3. So at 1 comma 2, meaning is in place of x you have to substitute 1. So 1 square is 1. So 3 into 1, it will be equal to 3. Now we know m is equal to 3, meaning is what? Tan theta is equal to 3. Tan theta is equal to 3. Okay. But actually this dy by dx is 3. We want dx by dy because we want it with respect to y-axis. So tan theta will be equal to what? Reverse of 3. That is, it will be equal to 1 by 3. Okay. So if they would have just asked x-axis, then the answer would be 3. But here they have asked it with respect to y-axis. So the answer will be what? 1 by 3. Option D will be the right answer. Okay. Next. Okay, next question. So they are asking us to calculate the local minima value of the function f dash given by, okay, f of x is equal to 3 plus okay, mod x belongs to R is, okay. So here what we can do is, see, first we need to take the derivative. So f dash of x will be equal to x which is greater than 0, okay. Okay, now see, f dash of x will be equal to -1. Okay, it will be equal to -1, which is less than 0. So f dash of 0 does not exist. So from this, what we can do is, see, f dash of x is equal to -1 is the local minimum value. Okay, at every positive real number, 1 is the local minimum value. Okay, as well as local minimum. Okay, so whatever the 1 is there, you get here, it is only the minimum value. Okay, it is only the minimum value. So therefore 1 is the only real minimum value. So option A will give us the right answer. Okay, next, question number 24 we will discuss. Question 24. So see here, let r be the radius of the circular wave. It is given that dr by dt, okay, dr by dt is equal to 5 centimeter per second, and r is equal to 8 centimeter. Okay, then area is equal to pi r square. Okay, so here what we have to do is, see, in the question 24, what they have done, see, a stone is dropped into a quiet lake. Okay, is dropped into a quiet lake, and waves move in circle, okay, at 5 centimeter per second. Okay, at instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? Okay, how fast is the enclosed area increasing? Okay, see here, so stone is what? It is dropped into a quiet lake. Waves move in circle at a speed of what? 5 centimeter per second. So the speed with which the waves are moving is given. Okay, and at that instant when the radius of the circular wave is 8 centimeter, how fast is the enclosed area increasing? We have to calculate. Okay, so since the, okay, waves are in circular form, we need to make use of what? Area of circle. So see here, let r be the radius of the circular wave, and it is already given. Change in the radius is 5 centimeter per second, and at r is equal to 8, we need to calculate the area. So see, area is equal to pi r square. Differentiate it with respect to t. So when we differentiate the area of circle with respect to t, we get dA by dt is equal to 2 pi r dr by dt. Okay, 2 pi r dr by dt. And then we need to replace it. Dr by dt is 5, and r is equal to what? 8. So when we simplify, 8 into 5, 8 into 5, it will be 40, and then 2. Okay, so 40 into 2, it will be 80. So 80 pi centimeter per second. Okay, so 80 pi centimeter square per second will be the right answer. Okay, next question. So see, I will be giving you 1 minute and try to solve it. See, very easy question. If x is equal to ct and y is equal to c by t, find dy by dx at t equal to 2. Okay, so this equation is given in parametric form. So you differentiate with respect to t and try to get the equations. Okay, so when you get two equations, dx by dt, find out dx by dt, and then find out dy by dt, and divide it, so you will get dy by dx. After getting dy by dx, substitute t is equal to 2. Quickly try to solve it and tell me the answer. 1 minute I will give you. Try. Okay, one of you have answered. Who is that? Yes, Vamshi Krishna has answered option D. Okay, so I will display the solution. You can just check it. Those who have not done, you can copy down. Okay, so answer option D is the right answer. So you have to make use differentiation of parametric function. Same steps you need to apply, and then on simplifying we get minus 1 upon 4. Okay, minus 1 upon 4. Next question. Okay, question number 26. A balloon, okay, a balloon which always remains spherical is being inflated by pumping in 10 cubic centimeter of gas per second. Now find the rate at which radius of the balloon is increasing when the radius is 15. Okay, so here what they have given is, see, a balloon which is always spherical in shape. Spherical in shape means it is a sphere. Okay, it is a sphere. So a sphere shaped balloon is what? It is inflated at 10 cubic centimeter of gas per second. Okay, cubic centimeter, so cm cube per second. So change in the volume is given. So using the change in the volume, we need to calculate what will be, find the rate at which radius of the balloon is increasing when the radius is what? 15 centimeter. Okay, so to solve this example, we are making use of the formula volume of the sphere. Okay, so we need to know the formula of volume of the sphere. Okay, so volume of the sphere, V is equal to what? V is equal to 4 by 3 pi r cube. Okay, and when we differentiate this, we get, see, dv by what? Dv by dt with respect to time, it will be equal to 4 by 3 pi. R cube derivative will be 3 r square. Okay, dr by and dt. Okay, so this will be the derivative, or 3 and 3 will cancel, so we get it in the form of, okay, 4 pi r square dr by what? Dt. And now see, we know it is 10 centimeter cube, so volume is 10 and r is 15. So on substituting, we will get the value of dr by dt. Okay, so we will go through the solutions if pay attention. Okay, so see, first we have to differentiate this. So on differentiating, what we are getting, 4 by 3 pi 3 r square dr by dt, or 4 by 3 pi, you can shift it to LHS here. So d will be equal to, so say dr by dt will be equal to 5 into 3 2 pi into 3 pi square, which is equal to 5 upon 2 pi r square. Okay, so on simplifying, at r is equal to 15, where there is r replace it by 15. Okay, so it will be 225. Okay, so 225 upon y, it will be equal to 5 upon 225. Okay, so on simplifying, what do we get? See, 1 upon 95 centimeter per second will be the rate of change of radius with respect to time. Okay, so option C will be the right answer. Okay, so again, this question is from rate measure. Rate measure. So here you need to know the volume. Okay, if you know the volume of the sphere, the example is easy. Okay, next we will discuss question number 27. Okay, so in question number 27, see what's given. The two curves x cube minus 3xy square, okay, and 3x square y minus y cube is equal to 2. Okay. So this is the question, and we have to check whether these questions are orthogonal, okay, that is right angle or cut at pi by 4 touch each other or cut at angle pi by 3. Okay, so first what we are doing is we are again using the same steps. So in the previous example we calculated angle between the tangents. The same formula we have to apply. Tan theta is equal to mod of, but before that we need to calculate. Okay, they are asking us to calculate the angle, okay, and tell at what angle they are touching each other. Okay, so first we will calculate that. So consider the equation 1. So in equation 1 what we have to do, see, first we have to consider the equation 1. So by considering equation 1, see, this is our equation 1, we need to take its derivative will be 3, okay, 3x square minus 3 into, we need to apply the product rule here. Okay, so it will be x into 2y divided by dx, okay, plus y square is equal to 0. Next, on simplifying further, again what do we get? See, okay, x square minus 2xy divided by dx minus y square is equal to 0. Or on simplifying we get dy by dx, okay, dy by dx is equal to x square minus y square divided by 2xy, and this is our equation number, okay, 1. So this is the slope of the first line. We are considering it as what? M1. Similarly, consider the second line now. So the second line is 3x square y minus y cube, okay, 3y square y, okay, 3x square y minus y cube is equal to t. Again we need to differentiate, apply the product rule. In the first case here we have to apply product rule, and y cube derivative will be 3y square divided by dx is equal to 0. So when we simplify we get, see, we get it in the form of dy by dx is equal to minus 2xy upon x2 minus y2 is equal to m2. But when we simplify, see, when we take the product of this, okay, when we take the product of this m1 into m2, we can see that uh, m1 into m2 will be equal to minus 1. Okay, so when you multiply these two, you will get it as minus 1. Okay, so they are at what? Right angle. Okay, they are at right angle. The curves are meeting at right angle. Next question. Next, we will discuss the question number 28 now. Okay, so if x is real, and then the minimum value of x square minus 8x plus 17 is, okay. So if x is a real number, we need to calculate the minimum value of what? We need to calculate the minimum value of x. Okay, so here we have to calculate minima. Okay, so whenever you are calculating maxima minima, you need to follow these steps. Okay, hope you remember the steps for maxima minima. So first the function will be given to us, f of x will be given to us. Find the first derivative and then find the what? A second derivative. Now to check whether it is maxima or minima, what you have to do? F dash of x is equal to what you have to do? 0. Okay, f dash of x is equal to 0. We need to do, and simplify and try to get the obtain of value of c. So this will be the points where the function will be maximum or minimum. So we will see that how we can solve it further. Okay, see. So let x square minus 8x plus 17. So first derivative is 2x minus 8. Second derivative, second derivative of this, and that is 2x minus 8. If you take the derivative once again, x derivative will be 2, its derivative will be 0. So we are getting, say, only 2 will remain. So we can see 2 is greater than 0. Meaning of this is it has a maxima. So to calculate the maximum value, you have to open your mouth. Okay, once again. Okay. So what you have to do is to find out the minimum value, we have to substitute now. Okay, we have to substitute dy by dx is equal to 0. So 2x minus 8 is equal to 0. We get x is equal to 4. Yes, we get x is equal to 4, and x is equal to 4 we need to substitute in the equation y. So that is at y, if you substitute x is equal to 4 in this main equation, here, if you substitute x is equal to 4, you will get the minimum value. So minimum value will be equal to what? 1. Okay, minimum value will be equal to 1. Yes, next question number 29. Okay, so here it's little different type. So here what they have done is, if p equal to x1 1x and q is equal to x1 1 1x1 and 1 1x, and then dq upon dx is equal to dq upon dx is equal to. Okay, so here p is given to us, and also it is given, q is given. Okay, so see, there are two ways of solving this. See the first way how we can do this. So first we have to take the determinant of p. We will get it as x square minus 1. Then determinant of q will be x cube minus 3x plus 2. Then differentiate q separately, and dx separately. So we get 3x square minus 3. And here when you differentiate x, mhm. Okay, so we can see that there are more terms involved. So see, dx by dq by dx will be equal to 3x square minus 3, or later, okay, 3 into what you get, x square minus 1. Okay, 3 into x square minus 1, which is equal to what, 3p. So in place of x square minus 1, they have replaced it by p. So 3p will be the answer. 3p will be the answer, that is option B. Next question. Question number 30. Slope of the normal to the curve is. Okay. So you all know how to solve it. Just I will give you again 1 minute. Try to solve. First find the derivative, because slope of the normal will be minus 1 upon. Okay. Minus 1 upon dy by dx. Simplify it quickly and tell me the answer. The point is given here. Okay. Add the point minus 1 comma 0. Okay. So see, after taking the derivative, we need to substitute minus 1 comma 0. Okay. So I hope you have solved it. You can go through the solution here. One of you answered yes, answer C. Okay. We will check it. 1 minute. Yes, option C is the right answer. Okay. So y is equal to x square minus 1 upon x square. Derivative we need to take, and then find out dy by dx at minus 1 comma 0 minus 4. But for tangent and normal, the condition is what? Slope of tangent is minus 1 upon slope of normal. Okay. So you have to make use of this condition and reverse it. Okay. So say slope of normal will be equal to what? Minus 1 upon slope of a tangent. Okay. So whatever the answer you are getting, minus 1 upon what? Minus 4. So when you simplify, we will get 1 upon 4. Okay, so 1 upon 4 will be the slope of the number. Okay. Next example, example 31. Okay. The slope of the tangent to the curve. Okay. At the point 2 comma minus 1. Okay. So it is similar to, I think, the question number 29 we had solved. Again, the curves are given in parametric form. So first we have to calculate what? Dy by dt, and then calculate dy by dt and dx by dt separately. Divide them both again. See here. Dy by dx we have done. So dy by dt upon dx by dt, we get 4t minus 2 upon 2t plus 3. So on simplifying, we get t is equal to 2. We will get it as 6 by 7. Okay. So 6 by 7 will be the slope of the tangent. Okay, next question, 32nd question. Yes, the equation of the normal to the curve y into 1 plus x square is equal to 2 minus x, where the tangent crosses x-axis. Okay, so tangent is crossing x-axis. So this is the hint given to us. So using this hint, okay, we need to find out the equation of the normal. Okay, so see here, what we can do is first the equation of the curve we know. So here we need to differentiate. They are saying the curve is crossing through x-axis, meaning is y equal to 0. So when you substitute y is equal to 0, we get x is equal to 2. So whatever the curve is there, okay, the curve, the given curve is there, it is touching which axis? It is touching, say it is touching the x-axis. So if this point is lying, you can make use of, so this point will be of the format x comma 0. Okay, so and simplifying, we get the point of contact as what? 2 comma 0. Okay, so at this point of contact, okay, we will try to get a tangent. Okay, now, so see, differentiating 1 with respect to x, we get, so when we differentiate, see, y as it is derivative of 1 plus x square will be 2x plus 1 plus x square. Okay, so on simplifying, dy by dx is equal to minus 1 upon minus 1 upon 2xy minus 1 minus 2xy upon 1x square. Okay, so this is nothing but the slope of the tangent. But yes, we want slope of the normal. So slope of the tangent we have got minus 1 upon 5, or this will be equal to what? 5 slope of the normal. Now we know the equation of the normal to the given curve which is passing through, okay, this point 0 comma 2 is given in the question. The point of contact is what? 2 comma 0. So when you, okay, substitute x and y coordinate as 0 comma 2, we will get the equation of the normal. Okay, so next question. So here they are asking us the maximum value of 1 upon x to the power x is. Okay, so we need to calculate the maxima. So see, let y is equal to 1 by x to the power x, and see, it is in the form of f of x raised to power g of x. Okay, so f of x is 1 by x and g of x is what? X. So here we are making use of the log on both sides now. So log y will be equal to x log 1 minus x minus y. Okay, so this will be the first substitution. Okay, see here. So what we are doing is when we differentiate, we get dy by dx will be equal to minus y into 1 plus log x. Okay, and this term we need to equate it to 0. So when we equate this term to 0, okay, when we are equating this term to 0, okay, so see, you can see that we are equating dy by dx. Okay, and dy by dx is equal to 0. So when we do this, we will get it in the form of, so say x will be equal to 1 upon e. Okay, now x is equal to 1 upon e. Okay, we need to substitute in his, okay, in the equation. So see, now differentiating with respect to x, we get the second derivative. The second derivative is negative, means it is having a maxima at what, at x is equal to e. Okay, it is having a maximum at x is equal to e. So on simplifying, we get the maximum value. The maximum value of 1 upon x to the power x is e raised to 1 upon e. Okay, e raised to 1 upon e is the answer. Okay, next question. The rate of change of area of a circle with respect to its radius is. Okay, so we know this is a very simple question. It has occurred on rate of change. So I think everybody knows what is area of circle. So say area of circle is what, pi r square. But here, instead of differentiating with respect to time, we need to differentiate with respect to r. Okay, so a by, okay, so what it will be when we differentiate, we get it in the form of dA. Okay, see, when we differentiate, we get dA upon what, dt is equal to 2 uh, 2 pi r. Okay, so say 2 pi r. So we need to substitute r is equal to 2, so it will be equal to what, 4 pi. So out of the given option, say option D will be the right answer. Okay, so we will also check the solution for this. Pay attention. So you can see the area is what, 4 pi. Next, the point of the curve y square is equal to x. The tangent at which the maximum. Okay, so here, so see the point on the curve y square is equal to x. The tangent at which makes an angle of what, 45 with the x-axis is. Okay, so the curve is given. We have to calculate the point of contact here. Okay, where the tangent at which makes an angle of what, 45 with x-axis. Okay, so here what we can do is see further. So see, first we have to consider the equation of the curve. See, whenever a question is occurring on normals and tangents, always you need to take the first derivative. Whenever a question is occurring on maxima minima, I try to take the first derivative as well as the second derivative. Okay, so that is the difference. So when we differentiate y square is equal to x, we get it in the form of, see, 2y dy by dx is equal to 1, which is equal to dy by dx is equal to slope of 1 by 2, slope of, okay, 1 by 2y we will get. And then tan theta is equal to, say, tan 45 will be equal to 1, so this will be equal to 1 upon 2. Okay, 1 upon 2y is equal to 1, or y is equal to 1 upon 2, or on simplifying we get the required points are what, 1 comma 4 and 1 comma 2. Okay, next question number 36 we will discuss. So in question 36, if see 36 it is, if the function is strictly increasing in the interval. So we have to calculate in which interval the function is strictly increasing. So here you have to take the first derivative. So once you take the first derivative, you will get f dash of x is equal to 1. Okay, is equal to 1. So what you have to do is 2x plus 2, whatever the derivative got, you have to write it 2x plus 2 greater than equal to 0. First question. Okay, so when we do this, we get see x is greater than minus 1. Okay, so in the given option, option D will be the right answer. Okay, option D will be the right answer there. Okay, so option D is from minus 1 to infinity. Next, question number 37. See the rate of change of volume of sphere with respect to its surface area when the radius is what, 4 centimeter. Okay, so here what we have to do is see the rate of change of volume of a sphere, whereas whereas the surface area when the radius is what, 4. So first what we have to do, we have to calculate change in volume, and from change in volume we have to obtain dr by dt, and once you obtain dr by dt, okay, so you will be getting it. So what we will do here is whatever, first we need to consider the volume of the sphere. Okay, so we will consider the volume of the sphere, and we are differentiating with respect to the area. So dv by dt is equal to ds by dt. So we get 4 pi r square dr by dt divided by 8 pi r dr by dt. Then on simplifying, we get r upon 2 is equal to 4 upon 2, which is 2 centimeter cube per second. 2 centimeter cube per second. So option A will be the right answer. Next, another 2-3 questions we will try to discuss. Okay, so approximation. Okay, so none of the question we have solved on approximation and error. So here we are solving this one. Say approximate change in the volume V of a cube of side x meter caused by increasing the side by what, 3%. Okay, so when you increase the side by 3%, what will be the approximate change in the volume. Okay, so as you increase the side, there will be change in the volume of the cube. Okay, that we need to calculate. Okay, so first what we have to do is they have told dx by x into 100 is equal to what, 3. Okay, is equal to 3. Okay, so on differentiating, see now v is equal to x cube. When we differentiate, we get dv by dx is equal to, okay, dv by dx, okay, v is equal to x cube, so dv by dx is equal to 3x square. Okay, it is equal to 3x square. So on, see, this is the formula here. I think in board level, while discussing practicing the examples, you might have done this. So see here, you have to take the change in the volume is nearly equal to what, dv by dx into delta x. Okay, so say first differentiate. So differentiation is 3x square into what we need to do, delta x. Delta x we have calculated here. So delta x we have calculated it as what, 3. Okay, 3x upon what, 100. So this will be 3x upon 100. So when we simplify, see, in place of dv by dx, we need to substitute 3x square, and delta x value from this it will be 3x upon 100. So when we multiply x into x, it will be equal to x cube. 3 into 3, it is 9, and upon 100, it will be equal to 0.09 x cube. Okay, meter cube. So this will be the change in the volume. Okay. Next, similar, one more question is given there. So pay attention. Similar on approximation and error. So this is a stationary point. F of x is equal to x raised to x as a stationary point. So here also we need to find out the derivative and equate it to 0. So take the first derivative. See, f dash of x is equal to, take the derivative, equate it to 0, and when we do that, we get x is equal to 1 by e. So 1 by e will be the stationary point, that is option B. Next, maximum area, just we have started solved it in the beginning, inscribed in the circle. Same procedure you all try to follow. Next, the interval also. Okay, so such type of questions is occurring from what, increasing and decreasing. Okay, increasing and decreasing. So we will discuss this. So pay attention here. So f of x is equal to x cube minus 6x square plus 9x plus 10. So we have to first take the first derivative. When we take the first derivative, see x cube and derivative will be 3x square minus 12x plus 9. Then try to factorize it. So when we factorize, we get x minus 3 and x minus 1. Okay. So now for increasing, f dash of x must be greater than equal to 0. So when this is greater than equal to 0, then only we get a increasing function. So when we simplify, we get 3 into x minus 3, x minus 1 greater than equal to 0, or x is less than equal to 1, or x is greater than equal to 3. See, less than equal to 1 meaning is it is from minus 1 to infinity. X is greater than equal to 3 means it takes the real values from 3 to infinity. And the union of these will be the interval where the function is what? Increasing function. Okay. Next, one more question we will try to solve. Okay, and this will be the last one. See, the sides of an equilateral triangle are increasing at the rate of what? 4 centimeter per second. The rate at which its area is increasing when the side is 14 centimeter is. Okay. So see, the sides of equilateral triangle are increasing at the rate of what? 4 centimeter per second. Okay. And the rate at which area is increasing when the side is 14 centimeter. Okay. So first we have to consider the sides, and then by using the formula of area of equilateral triangle, we can simplify it. So see here what we are doing is let x be the side of an equilateral triangle and a be its area. So dx by dt will be equal to what? 4 centimeter per second. Next, area, when we differentiate dA by dt, we get root 3 upon 4 into 2x into dx by dt. Okay. So next what we will get is x is equal to 14 when we substitute. So dA by dt is equal to root 3 upon 2 into root 14. Okay, because x is equal to 14 into 4. So when we do this, we get 28 cube root of 3 centimeter square per second. So the options are incorrect. So they have got grace marks in that particular year. Okay. So we have discussed a few examples on this, and then see, this is a standard question. Most of the time they ask it. The value of what? Root 24, 24 minus what? 24.99. So here this we have to solve by making use of approximations and errors. So this is the last question we will be discussing. So since they have asked square root, you have to consider x as root x, and you have to take the derivative of this. So f dash of x will be equal to 2 root x. Next, we have to consider for 26 what must be the term. So it will be 25. Okay, 25 minus what? 0.001. So 25 at x is equal to 25, we can substitute, and see we can have the formula here. Use of the formula, f of x plus what? Delta x minus f of x is equal to f dash of x into delta x. So when we simplify, see what do we get? F of 24.99, 1 upon 2 root 25. Okay, minus 0.001 plus root 25. So when we simplify, we get the square root of what? 24.99 is what? 4.99. Okay, so this will be the answer. So we have discussed few questions on these application of derivative. In tomorrow's class, we will be discussing few questions on probability. Okay, so we will stop here today and take care. Okay, bye.